Assalamualaikum. Okay, so this is the third part of this series. So first we designed the controller for this magnetic levitation plant. We observed the results, and then we saw that different values of these gains will give you different results. So we decided to go ahead and use optimization algorithms to get the best values of these gains, and we used genetic algorithms, and we designed all of this to compute this final error, which error was used by the genetic algorithm to get these values. So once we have this optimized control law, okay, with these optimized values, so we got our final results. So now what we have to do is we have to evaluate some of the performance indices and some transient characteristics. Okay, so what we have to do is we need to use some of these two workspace blocks more. Okay, so I'll just go ahead and set its settings to this. It should be a 2D array, and I can name it an x1. So my x1 state, the actual output of my system will be going to this x1 variable. I'll just make a copy of this, and I need this x1 reference, so I'll just rename it to x1 reference. Okay, so I'll do the same for the rest of these two results and the rest of the results or states that I would have for different systems. For now I'm just giving you an example of one of these only. Okay, so let's run this simulation, and what I would observe is that these two variables are supposed to appear at this point in this MATLAB. Okay, so once the simulation is done, well, it is done. Okay, they should appear. Okay, there. Okay, so since we had the same step size, 1e minus 5 fixed step discrete, and we had this discrete solver as well. So if you don't understand this, so go to model settings and just ensure that you have a fixed step size. Okay, 1 minus 5, 1 is minus 6 is good enough. Discrete with no continuous states, and you have the arrow format here, and this part is untick. Okay, so once you have these settings, you will have the same dimension of variables at this point. Okay, so if the dimensions are not same for any of this, well, this method will not work. Okay, so we are going to save this t out variable in this t part, and we will be plotting one reference line with this x1. This is the x1 variable with respect to time. We will use the hold on command so that the next plot is plotted on the same figure. Okay, and then well, we can define the legends as well. Then we have this step info command. Okay, step info of this actual variable with respect to time. This will give us the settling time, rise time, peak time, the transient characteristics. So this will be saved in this specific variable, so we can just go ahead and maybe well, run this code. Okay, so you go ahead and click on this run button. So this is compiling and so on. Okay, so in the meantime we can just look at the corresponding output results as well. Okay, so this is our figure with both of the results. You can just go ahead and click on this arrow to open it in a bigger file. Okay, so and then we have our step info. Okay, so this is our step info. So the settling time is 2.3995 seconds, the rise time is this, the undershoot, overshoot, and the rest of the details are mentioned here. So we have our steady state error as well. So steady state error is minus 0.4924 for this specific state. Okay, so then this is the sampling time that we described over here as well. Control E, and in the solver, here's your fixed sampling time. So we needed this here as well. So this is the same sampling time as that. So then we used these formulas, which you can observe over here. Okay, so I just scroll it so you can just maybe pause the video and rewrite them. So this is the mean, these are the performance indices, right? So mean absolute percentage error. So the mean absolute percentage error of this control law for this state is 10.4137. The root mean square error The integral scale error, the again, I apologize, this is a repetition maybe. No, well, yeah. So integral absolute error, I believe it is. So integral time absolute error, and then we have the integral time square error, then we have the mean square error. Okay, so for each of the corresponding states, here we have the corresponding values, and well, yeah, these tell you a lot of details about the system. So this is your graphical analysis, and this is your transient characteristic analysis, and this is your performance indices. You can well compute different other performance indices as well based on your method or whatever you want to compute, because all of these will give you different information about different stuff. So well, this is how you compute all of these details. Okay, so again, if I wanted to compute all of these things for this x2 state, I would do the same. I would send two more, one the reference value and the other one will be the actual state value, and then I will just change this wherever. I will just press Control F and I will see wherever x1 reference is written, I would write whatever I want to write, maybe x2 reference. Okay, and I'll replace all, and then well, we can go ahead and do that, replace all, and then we can just select this, press Control F, and maybe we can replace this x2 with well, x2 reference. And if we run it, it will not work because there is no x2 reference or x2 at the moment. Okay, so we'll just go ahead and delete all of this state as well. So if we do this, the same procedure for x2, okay, so let's rename it to x2 and this to x2 reference, and we'll just play it here and there. So we have the x2 state and the x2 reference state. Okay, so now let's run this simulation. So at the end of this simulation, I would expect an x2 reference and x2 variable at this workspace. So once it is in this workspace, this code will run and it will give information about the second state. Okay, so the code is done. So we have this x2 and x2 reference, and now that it is here, we will see that okay, here we got the plot and the results. Okay, so this is the transient characteristics with the rise time, transient time, and all this and that. For the second state, we have the steady state error for the second state, and we see the performance indices of the second state as well. Okay, so similarly we can go ahead and do the same procedure for the third state and fourth and so on. So this is how you evaluate this analysis, and then you can, well, in your research paper you can go ahead and put, well, this controller with this algorithm gave this rise time over to overshoot and the rest of the characteristics, and this controller with this algorithm gave all of these performance indices. Okay, and along with this graphical analysis, because it is not very logical to ask someone to just go ahead and look at the graphs and observe which was best, which was better. You need mathematical analysis. These are well, these will support your claim, which performed better, which control technique or which method was better. So you can go ahead and put this into a tabular form, and this is how you do it. Okay, so I believe that's done for now. Take care. Allah Hafiz.